All right, guys, let's talk about adding vectors. So before we go any further, the first thing I want to tell you to do is when we're adding vectors, you need to check and make sure that their units match. So before you add any two vectors, stop and check that their units match. If their units don't match, we're going to have to convert before we can do anything. And that's the most important thing to take away from today. So being able to add vectors is a really important skill in physics. Since vectors have direction, their magnitudes can't be added together like numbers. They need to be drawn and added tip to tail to determine their sum. Because sometimes a vector might be going east and then north, and then east again, and then west, and then northeast, and we need to figure out where that person went. So we're going to look at this in context of a problem. And then we're going to go through the step, or the steps, I guess you will. So our problem is a child runs in a park 16 meters east, 20 degrees north. Then 12 meters east, 20 degrees south. Draw the resultant vector. So what is a resultant vector? What is this? So the definition of a resultant vector is the sum of adding the vectors together. And it begins where the first vector begins, and it ends where the last vector ends. Sorry, that's hard to read. I need to get my new markers. All right, so the very first step is to draw our first vector using the proper steps. So step one, let me see, maybe my blue marker is sharp, is to draw the first vector. Not so bad. All right, so I'm going to look at this. And my first vector I need to draw, or my first change in displacement, is 16 meters east, 20 degrees north. Okay, so if I follow my steps of drawing a vector, I need to make my compass. All right, I'm going to lay this down. And I'm not quite straight there. That's a little better. All right, so I'm going to go east, 10, 20 degrees north. And I have it marked. And that's going to be 16 meters. Okay, so I could make that 16 meters, but my paper's not big enough for that. And I could make it, if I can get this together, I could make it 16 centimeters, but my paper's not big enough for that. So I'm going to go with 16 millimeters. So I'm going to line my 0 up over here. And I'm going to make this just a little bit bigger so y'all can see. And this is my initial displacement. All right. But that's not where she stopped, right? After she ran 16 meters, 20 degrees north of east, then all of a sudden she ran 12 meters 20 degrees south of east. All right. So step number 2 is to begin the second vector where the first ended. My second vector is 12 meters east, 20 degrees south of east. All right. I need to set another compass here, with the very center of that compass being where my first vector ended. All right, and she went 20 degrees south of east. So here's east. I'm gonna set my compass, and I need to go 10, 20 degrees south. It's off my paper. I'm gonna mark the table really quick. And I'm gonna draw my vector. I'm gonna finish it with an arrow. I'm gonna label it. This is my second change in displacement. Make sure on your second displacement, you end it with an arrow at the point where it ends. So you need to have 2 arrows here, the arrow that ends your first vector and the arrow that ends your second vector. All right, last but not least, the resultant vector. Begins with the first vector and ends with the second vector. So I'm going to use a straight edge. I'm going to connect the 2. So the beginning of the first vector, the end of the second vector, and there is my resultant vector. And it needs an arrow again where that ends. And the main question I get when we talk about vectors is this: does order matter? And the answer to that is no. At some point, you should have learned the commutative property. And that commutative property covers us here. All right, so there's 3 different strategies to add the vectors together. The first type of vectors are collinear, and that's what we did this last unit. So we're going this way, and then we're traveling back the same way. So we've already talked about how to address those vectors. The next set of vectors we might run into are perpendicular vectors. So if we have perpendicular vectors, we've got something like this going on. So perpendicular means we have a 90-degree angle somewhere. So when we're adding these 2 together and trying to figure out this resultant vector, we're going to use the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. So a, b equals c. But that helped us out, but we need to know the angle of the resultant vector. What angle was that? For that, we are going to use a little bit of sine law. So we can say if this angle is theta, the tangent of theta is equal to the opposite line over the adjacent. If this is our 90 degree, this right here, this line is our opposite. This down here is our adjacent. So the Pythagorean theorem is going to give us the length of our resultant vector. This right here is going to give us the angle of our resultant vector, or the angle of theta. All right, what if they're not perpendicular? What if I have got two angles like this, and it's long and skinny, like what I drew at the top? And here's my arrows. And I want to find this resultant vector in theta. The first thing I'm going to do is use the cosine law to determine magnitude. All right, the cosine law is in your formula folder, but if you need a review on it, I'm going to put it down here at the bottom. So the cosine law says that c squared is equal to a squared plus b squared minus 2ab cosine c. So we have a, b, c. So you'll plug in the values for a and b because you'll have those because those will be your two vectors. You'll plug those in, and that will give you the magnitude of this resultant vector, or the length. All right, then for step 2, we're going to use the sine law to determine the angle. All right, and the sine law. I'm going to put it over here. On my paper, I have them written up the side to help me, but on here, it'll be easier for me to put it over here. So the sine law says that the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. You might have to interpret this a little bit to get the right angle. So you might have to work and manipulate this a little bit to get the right angle. If you forgot what all this means if you have a triangle, this is capital A, capital B, capital C. Those are your angles. A, side C, and side B. So if they're non-perpendicular, you're going to start with the cosine law, determine the magnitude of this, then use this sine law to figure out the angle of theta. And that is how we add vectors and figure out resultant vectors.